Jeremy Cohoe, Technical Marketing Engineer with Cisco Systems. I'm also joined today with Story DeWeese. We're going to be covering energy management for Catalyst for the next hour or so. This is our iOS XE device telemetry workshop. You might have seen the blog. You probably already signed up. Here's just a brief overview of what we're going to be covering. We're going to give you a lot of examples, a lot of code samples, and a lot of hands-on examples for where you can get device telemetry and the entire ecosystem supporting it, including the Yang Suite tooling and the Telegraph, Influx, and Grafana Docker container that we've prepared and we've been sharing for the last couple of years. So we've kind of 7 major sections. We're going to be going back and forth quite a bit amongst ourselves here. Between the slides, which is describing some of these solutions and the examples and the technologies, and then some demos where we've actually reserved some of these environments. We've got some demos preloaded where we can go in and actually show the end result that we can see as we go through a lot of this stuff. So let's jump right in. We'll get into the lab environments. First and foremost, we have the iOS XE device programmability website over here at developer.cisco.com/iOS-XE. Like it says here, it's our one-stop shop for all Cisco iOS XE programmability resources. We have a lot of videos, blogs, our white papers, and specifically for today, we have the sandboxes. We're going to be using or make some examples to the always-on sandbox. We also have the reservable virtual and reservable physical sandboxes. These are available. Some are always on, some are always and some are reservable with different capabilities and different resources. We have learning labs and blogs over here specific for telemetry. So we have a learning lab on the first link here in the QR code. You can scan that. You can get a walkthrough guide on the developer.cisco.com Learning Labs platform. We also have some blogs that describe these features that link to some other resources, including the learning labs. And then we do have a bunch of videos on YouTube that link to some of the resources that we've posted over the years about streaming telemetry, about dashboards and collection, and a whole bunch of other topics around device telemetry. So some of the sandboxes that you'll see today, as I mentioned already, is the reservable, the always on. We do have the physical reservable, but they're not quite ready yet. We're working with the teams to get those stacked, racked, and configured. We're getting pretty close, so we'll be there probably within the next quarter. But today, you'll see the reservable virtual sandbox. We can access this on developer.cisco.com or devnetsandbox.cisco.com. We have a variety of iOS XE, NX, and XR virtual devices in here. We also have this enabled for a bunch of different use cases, including telemetry and Yang Suite, of course, not which is what we're going to be using today, and Terraform. But we also have Ansible, ZTP, Guest Shell, a bunch of other resources within this reservable virtual sandbox. So definitely encourage you to take a moment now to reserve this virtual instance if you don't already have a BYOD lab environment that we'll be talking about shortly as well. So this is the reservable virtual, but we also have the always on. So some examples that you'll see will leverage the DevNet sandbox, iOSXE.cisco.com. This is our Catalyst 8000 virtual router. We have the login credentials here. You can access this from anywhere on the internet. You can access the SSH, netconf, or restconf APIs directly using the credentials here. And you'll see us using these with Yang Suite to get some of the information from the APIs. We can also leverage some of the streaming telemetry from these devices as well. And just a teaser about what's coming soon with the physical reservable sandboxes. We have a bunch of Catalyst 9300 switches, 9300Xs, the latest, greatest. These are all enabled for application hosting use cases as well. They have the SSD inserted. But we also have some of the other members of the family, the 92, 93CX, 9300L, and LM. So a lot of different variants within the Cat9K family that you can reserve, get the physical environments, and then actually do some API calls against some of the physical sensors that are in this equipment. So specifically, there's sensors for the fan, the power supply, the temperatures, and we'll talk in detail about how to instrument and get these type of details from the API coming up. Another environment that's available, or a lab environment, is within dcloud. Story is going to show us this coming up, where we can actually reserve this virtual environment, get access to a lab topology with some virtual switches, virtual clients, virtual devices. And we also have a services virtual machine in here that has all of the tooling and tool chain available. So we can demo, validate, and use all of the APIs in a lot of these use cases. Again, this is all virtual equipment, so the sensors that I mentioned previously are not always available in this virtual equipment. Now, getting to the BYOD component of this lab here, we wanted to take a minute just to talk about the lab architecture and some of the requirements. We have the QR code and the link here for the Cisco iOS XE MDT repository on the GitHub page here. This is a detailed lab guide that describes model-driven telemetry and specifically the gRPC dial-out features. So some of the requirements today, obviously you're going to need an iOS XE device. In our case here, we're using a 9300X running 17.1 plus. Really, most iOS XE versions and hardware-software combinations support telemetry. Certainly anything within release 17 has support for the majority of the model-driven telemetry features across all of the Cisco hardware platforms. We also put some of the CLIs on here. You do need to have the APIs enabled, netconfing, RESTconf. You do need some, a user, and then the AAA requirements for that user to be able to log in and make some config changes. On the networking side here, for gRPC telemetry, it does use a TCP port to push that telemetry data from the switch to the collector, to the laptop or the MacBook, the virtual machine, or the Docker instance. Right, so you need to have either your ACLs or firewalls enabled in a way and routing network access in a way so that these TCP packets can reach from the switch all the way out to your laptop or your Docker container, your services virtual machine, or wherever your compute is hosted. So with that, let me pass it over to Story to talk about the dcloud reservable environment.
Awesome, thank you, Jeremy. So we have over in dcloud a place where you can go and learn more about programmability and actually get some hands-on with these different topics here. So we'll go through these steps together, but just as an overview, you have the QR code and the links here. We're going to go to the programmability dcloud, and we'll go into this environment. We'll actually schedule a session. And in this case, we're going to schedule a single session, and we can go ahead and use our develop and test or develop DevNet option and go ahead and schedule it. So let's get into how this works over in dcloud. And also, this is what we'll be doing once we can actually access and have the session scheduled. So here we'll go to our hub over in dcloud, and we'll actually be able to see the session that we have just scheduled. Once this is ready for us to go, we can schedule it, a few days or weeks in advance if we would like to. We can go ahead into our workstation and get into the remote access, and then get into the web RDP. So next we can go ahead and start using things and getting hands-on with it. So now let's go ahead and take a look at how this actually works. So here I am over in dcloud, and I'm in the San Jose one. You can click a different region based on your current location where you're at, which one may be the most relevant to you. So I'm going to hop over to the catalog first of all, and I'm going to search for programmability. Let's see. Just got to spell it right over here. Programmability. Oh, I've got it saved. So I'll search for this one, and we'll see that we have the Cisco Catalyst 9000. This is the one that we actually want to work with. So we can go ahead and click on this to see more details. We can read the related or relevant documentation. And here's an overview of what we can actually do in this environment. So let's go ahead and schedule a session. We'll just schedule one for now. It brings us up with a calendar here. So say I want to schedule one for a couple hours, I can go ahead and click next. This one, we can use DevNet as our option. For now, I'm going to put not applicable, and for me, I'm at Cisco Systems and I'm a TME. So we can go ahead and schedule this. And you can see that this is scheduled. So I'll get an email once this is actually available, and we can go ahead and access it there. But I have gone through this process earlier and already reserved a session. So you can see with this dcloud session, I can go ahead and view it once it's ready. So here, this takes me to the overview, and I'll go ahead and look at the workstation here. I'll just open up this remote access and go into the web RDP. And this is how we can actually get the hands-on and start working with all of these different operations. So you can see earlier I was working over in Yang Suite, building up some payloads and actually going out and getting some data from the devices that are here within dcloud. So these are all virtual devices that you'll be working against here. So throughout this session, we'll be moving over to different environments that actually have the hardware that we'll be working with. So this concludes how to get started with dcloud, how to go in and schedule, reserve a session, and then get into it and start working with it. So with that, I'll pass it back to Jeremy.
Right on. Thank you for the demo there, Story. So that shows us how to get into the environment, where to find the resources, and some of the capabilities of the dcloud environment. So quite a lot to sit. It might take a moment to reserve those, to get the emails, to get into the environments. So while we do that, let's take a few minutes to understand some of the capabilities in detail that we're going to be seeing within some of these lab environments. Let's start by understanding iOS XE. We call this the industry's most open network operating system. It's receptive to a wide range of management and orchestration strategies, as you can see here across the device lifecycle. So we start at day 0, go through day 1 and 2, which is where we're focusing today, which is model-driven programmability and model-driven telemetry. But of course, this also extends to the day end, the software management capabilities as well. So whether you're using Cisco networking controllers, which are things like Catalyst Center, Cisco Meraki, or vManage for SD-WAN, we also have some other Cisco software solutions like NSO, the Network Services Orchestrator, or Crossworks, which is another set of solutions. Or if you're using third-party or do-it-yourself tools, we've listed some of the common ones here: SolarWinds Managed Engine, Puppet Chef, as well as what we'll be working with more currently, which is Terraform, Ansible, and Grafana. Splunk also sits in here. I don't know if it sits in the left or the right anymore, but again, Splunk is another tool that's recently joined the Cisco ecosystem for visualizing and storing telemetry data. This also extends to some of the homegrown tools that are supported within the device lifecycle and ecosystem, which are Python and Go. And we do have some integrations within Yang Suite for Python and Ansible. So quite a lot of capabilities directly on the device side. And if we take a little bit more deeper dive into the device lifecycle here, the enterprise network automation, that's enabled with Cisco iOS XE programmability. Again, across this 4-day life cycle of deployment, configuration, monitoring, and then optimizing. We have more details specifically about some of these features, but again, today we're focusing on day 1 and day 2, which is the netconf, restconf, and GNMI APIs, where we can get data from and understand some of the sustainability and raw data that's available from the devices. But also this extends into model-driven telemetry as well. So today, we're going to be using gRPC dial out. We're going to be receiving telemetry data from the device and then visualizing it. Throughout today, we're going to be using Cisco Yang Suite. This is tooling that we've been working on for a number of years that supports all of the APIs and the telemetry features that I've just described in the previous couple of slides here. So we can use Yang Suite to interrogate the API, to do gets and sets, to do configuration management use cases, but also for telemetry use cases as well. Story is going to be giving us a bunch more examples and getting into a lot more details about Yang Suite and the capabilities coming up towards the end of the section or more towards the middle. For now, you'll see it's available at developer.cisco.com/Yang Suite. And you'll see some demos and examples coming up later on where we can either manage the installation through Docker installs or directly using pip. So getting back to the iOS XE device programmability and telemetry APIs, we're familiar with CLI, SNMP, and the web UI, some of the legacy mechanisms for managing the device. But of course, now we support a variety of APIs. netconf, restconf, and GNMI are the APIs that we can use for config management. And then gRPC is our specific telemetry or push-based telemetry interface. All of these APIs are connected to the Yang data models. We have different flavors or varieties of the Yang data models. But they all support the configuration data model as well as the operational data model. So you can get the running configuration, but you can also get the show commands or operational data from the device features that are listed down here. As far as the model-driven telemetry API goes, it's a very similar story where we have dial in and dial out telemetry interfaces. Again, today we're using gRPC, so this is our dial out telemetry interface. So telemetry is pushed from the device to the collector based off of configuration. And we're going to see some of that configuration coming up. We're also going to see some options for managing that configuration using the Terraform tooling. We're going to see a demo using Terraform to manage the dial-out configuration. So as you can see here, there's a couple different telemetry interfaces. So we put this reference slide up here so you can have a better understanding of the comparison between these three interfaces, about when they're supported, the recommended version, and then some of the options for encoding and the security as well as transport that's available. Now, really what helps you understand or pick one of these over the other are some of the options that we've listed out here on the right, which is your network architecture, your security posture and policy, and then some of your preferences for tooling and software architecture. Now, regardless of which telemetry interface you use, they do have different characteristics as far as speeds and feeds. And that's because of the encoding and some of the transport mechanisms. So we put some information on here to help you understand some of the cost of telemetry, some of the cost of the various telemetry interfaces when we did some testing. Some of the testing that we did in this case was using 17 unique XPaths. And we collected these at a 60-second update interval. We collected these for 60 minutes or 1 hour, and then we summarized the results below. So depending on the telemetry interface that you're using, you're going to have a difference of the packet capture data, the amount of data that was actually sent, the data byte rate and bit rate, as well as the average packet rate and average packet size. So these can help with some calculations as far as storage, visualization, and some other telemetry use cases. Now, when we're talking about some of the publication options for the telemetry, basically we have on-change and periodic. So on-change is as it sounds here. It's for an event notification when the event happens. Some of the events here are listed out like a failed login or an optic fault. So we can get an on-change notification when either of these or many more events happen. But we can also subscribe to the data at a periodic interval. And that's what we're using today. While the device supports a minimum of 1 second update, we normally use a much higher update interval around either 30 seconds or 60 seconds. But sometimes we go up to 5 minutes, 10 minutes. We have some use cases that are even maybe once an hour or once a day to send a telemetry update. Now, when we're talking about the telemetry updates, let's take a moment to understand the overview of the ecosystem that's involved here. So at the very top, we have the Cisco iOS XE devices. And today we're going to be using the gRPC dial out or the configured telemetry to push data from these devices to our collector or our receiver. In this example today, we're going to be using Telegraph. Telegraph is going to decode the data from the format that it was received in, which is gRPC, and send it to storage. It's going to send it into our time series database storage engine, which is InfluxDB. And then we're going to use Grafana to make calls into Influx to visualize this telemetry data over time. And that's what we see represented on the Mac display over here. Now, all of this is documented, again, in the lab guide that we've listed below. And then the Docker container is also available on Docker Hub. So we've pre-packaged all of these containers, some of the scripts and examples, as well as the dashboards into the Docker container. So you can pull that down and get it used in your environment. Some of the Grafana examples that we've created and included in here, we've listed out for switch health, or wireless client stats, as well as for PoE view. So with this, let me pass it over to Story to describe a little bit more about Yang Suite and how we can actually understand the data that's driving a lot of these dashboards.
Awesome, thank you, Jeremy. So let's get into Yang Suite here. So first of all, we need to start by talking about the Yang models themselves. So we use Yang models to actually describe the data that we'll be using and working with whenever we're talking about anything, whether it may be telemetry related or configuring our devices programmatically. So here we have an overview. All of our data models are posted publicly over on GitHub. So you can check them out and see examples of how these Yang models are actually written and how they're working. So all of these models are organized by the specific software version or release that we have. And then within each folder of software release, we have a few different ways of categorizing these Yang models. So you can see that if any of the Yang models have Cisco iOS XE native, that's anything that you would see reflected over in the running config. And if you see an Cisco iOS XE and then a feature name and CFG afterwards, that's for feature configuration. Similarly, we have the same for Oper or operational data and RPC and events. We also have an example of Cisco EVPN services for the EVPN service abstraction. And if you're looking for OpenConfig models, we have OpenConfig and then the feature name. So this is an overview of how we actually organize all of our Yang models and how you can find them over on GitHub. So next we can move into talk a little bit more about how to use these Yang models and how to visualize the data. So for that, we'll be using the tooling Yang Suite. And here this is available. There are a few different QR codes you can go to check out more. But at a high level, Yang Suite is an API testing and validation environment. So this is a tool we can use to make sure that we know how the APIs work and how we can work with our devices programmatically. So we can actually build up payloads within Yang Suite, whether that be using netconf, restconf, gRPC, or GNMI. And it works across many different Cisco platforms as well. So let's get into it a little bit deeper. There's a lot included within Yang Suite. So this is the overview of all the different releases and the newest features that have been included in all of those releases. And today we'll be focusing on netconf, GNMI, and then we'll also talk a little bit about gRPC telemetry. So let's get into it. First, as a quick start, you can use Docker for Yang Suite. So here we have the steps. First, you can do a git clone of the GitHub page. You can build up your certificates and then do a Docker compose up. So now you'll actually be running Docker locally, and then you'll be able to go in and add your different devices to actually work against them. So now let's talk a little bit more about Yang Suite and telemetry here. So to get started, one option is to use the always-on sandbox with Yang Suite. So if you've just created or built up Yang Suite using Docker, you can now go in and set up a new device. So if you don't have a device or want to use the always-on sandbox, you can definitely go ahead and do this by going into the setup. You can go to device profiles here and create a new device. So this is where you can use the Cisco always-on sandbox. And for this one, we have added all the information that you'll need to actually add this device into your Yang Suite. So first of all, you can add in the profile name and the address that's listed here, as well as the credential. So once you've actually added this device, you can check the connectivity to make sure that you can actually access, so you can ping the device, you have access to GNMI, netconf, and restconf. So with that, we can get into a little bit more about how do you use Yang Suite once you actually have a device set up and ready to go. So to start off, we have one example using netconf. So with this one, we'll be getting back some data from the device about our platform Oper. In this case, we'll be using netconf. We also have a demo showing how to do similar call against your device using GNMI. So let's get into those demos and actually check them out live. So to start off, I'll just go to my current Yang Suite. You can see I'm running locally. And first we'll do the netconf example. So I'll pull up my Yang set. I'm going to go to the platform Oper. So we can go ahead and load this module up, and I'm going to do a get against my device here. So in this case, I want to get the components, component, and CNAME. And then within platform properties, I want to get the platform property itself. So let's go ahead and build this payload up and run it. So this should be telling me all the different platform properties. So this is what Yang Suite was able to generate for me. This is netconf XML. And you can see we're running the get. We're saying, hey, give me some information about the component, specifically the platform properties, and all platform property data. Give that to us. And then we can see the reply here. So we were able to connect to our device successfully and get the data back. So we can see there's some fan data here. We've got a few fans. We've got the switch data as well. And then all of the information below giving us more detailed information about the platform itself. So now we can get similar data using GNMI as well. So I'll open up a new browser, again connecting to the same Yang suite here. I'll pick out the Yang set and go again to the platform opper. So we'll load this up here. I'm going to do a get operation again. I want to get all of the data, and I'm going to change the origin to the RFC 7951. And I'll keep the encoding type as the default, the JSON IETF. So for here, we're going to ask for components and component. For the CNAME, I'll add the wildcard here. And then we also want to get the platform properties, platform property. And again, I'm going to add the wildcard for all the names. So let's go ahead and build this up. We can see what Yang Suite has generated for us, and then hit run to actually invoke this against our device. So you can see there's a lot of data coming in here. Again, this is what we sent was the GNMI get, and we want to get all of this information about the component and the platform properties. So we can see the similar data coming in, but now we're just using a different protocol, GNMI instead of netconf. Again, we see the fan information as well as the switch information down below. So we're able to see here that regardless of which protocol we use, we can get that information from our device and actually work against it. Now I'll go back to our slides briefly to talk about how we can use Yang Suite with telemetry as well. So Yang Suite can be used as a telemetry receiver. And in this case, we're going to be using gRPC. So if we have a subscription that's configured over on our device, we can actually use Yang Suite to collect that telemetry data. So here within the gRPC telemetry, we can add our address and the port to listen at. And then we can see the data that's coming in at regular intervals here. So in this case, we're looking at CPU utilization. And again, this is for testing, for validation, to make sure that we're formatting our subscriptions correctly and able to receive that data somewhere. But in a production environment, we would be sending this data somewhere else. So we could be sending it to a telemetry receiver or collector. And in this case, we'll be talking a little bit more about Telegraph, Influx, and Grafana. So with that, I'll pass it over to Jeremy to get us more information.
Cool, thanks, Story. So yeah, absolutely, we can use Yang Suite to get information from the APIs, but we can also use it as a server or a listener to receive that telemetry data. So instead of using Yang Suite, though, let's talk about using the Docker container, right? Because the Docker container has Telegraph in it that acts as a server, a production-ready server that we actually see a lot of customers use in production in a variety of forms and formats and deployments. A lot of times it's based off of this pre-built Docker container here that we call TIG-MDT. Again, it's pre-configured to have these components in it, as well as a bunch of other tooling, as well as dashboards in it. So how does this work? Essentially, it's a Docker pull, and then it's a Docker run to turn the container on. Once you have the container turned on, we just do expose 2 ports. So it's port 3000, which is the Grafana port, and that's port 57500. Now that's the TCP port, again, that we're sending the telemetry from the switch on, and that we're going to receive it inside the container and pass it into the Telegraph tool to receive it and decode it. And that's what's happening here when we actually go into the Docker container. Right? We run the Docker exec and check the processes that are running, and we can do validation that Telegraph, Influx, and Grafana are indeed running. In our example here, we already have data sending from the switch to the collector. So we've sent these commands, these CLIs, we've done some show and some validation, and we've also used Yang Suite to look and understand at the data that's being sent. You know, in the screenshot example here, we have the environment opper or the environment sensor data that we're going to be sending. So what do we do if data is not received once we've put this configuration in and turned our services, our container on? Typically, we recommend to do a packet capture, and we have the example in here of how to do that packet capture, which is essentially on the switch on the Docker container itself, as close to the application as possible. So this is actually right next to Telegraph. We can just run a TCP dump, listening on that TCP port 57500, and we'll actually see the packets coming in as they're sent from the switch. And once we've done that, we can actually validate that the data is received or decoded by the Telegraph tool. We can do this by tailing out the Telegraph gRPC log that's actually being written out to disk. With that, let me pass it over to Story to actually show us this in action.
Nice, thank you, Jeremy. So let's go ahead and take a look at this live. So in this case, we have a pod over here. This one is a virtual machine that's actually connected to a 9300X device. And so to go ahead and get this Docker container, let's run a Docker pull here. So I'm going to go in and actually pull this data down, and we're going to get the Docker container here. This one has the Telegraph, Influx, and Grafana all packed in with it, as well as a version of Yang Suite. So we've downloaded the newest version of Yang Suite, of the Docker container, and now we can go ahead and run it. So we see that it now should be running. Let's just confirm that that's true. We can run a Docker PS to go ahead and take a look at this. And we can see, yes, okay, the Docker container itself is running. This one has been up for 7 seconds, so we just turned it on. And now we can actually go ahead and get inside the container. So let's run a Docker exec IT, and I'm going to use the container name here and open it up in Bash. So now we should be able to see that everything is running as expected. So I'll run a PSXA, and we can see that Influx, Telegraph, and Grafana are all here. So we know that the environment is set up and everything is working as expected. So now, assuming that we have a telemetry subscription already created on our Catalyst device, we can go ahead and see that data streaming in. So I'm going to actually look at our Telegraph logs here to see if there's any data. And in this case, you can see there's some CPU data that's already coming in. So we know that everything is actually set up and working as expected. So we're able to get data from the device and send it over to this Docker container, where then we can collect that data and we can eventually build up some telemetry dashboards and look at that data over time. So with that, this concludes the Docker explanation, the demo, and now we can move back into an overview of Terraform. So next we'll be using Terraform to actually manage our telemetry subscriptions here. So first of all, what is Terraform? Terraform is a declarative infrastructure as code cloud native tooling, and it helps manage the processes through code rather than manually using them through CLI. So we do this by creating or writing, describing our end result that we're interested in rather than all the individual steps that we want our device to take. So we don't need to, say, configure a no CLI if we want to remove something. Instead, we'll just say what we want the end result to be, and then Terraform will understand if it needs to add config or remove config to get us to that desired end state. So you can read more about infrastructure as code here, or we have some additional details about using Terraform and how to access it. So we have a Terraform provider, and it's for Cisco iOS XE specifically. There are a lot of different providers out there for different use cases. And in this case, you can go to the Terraform registry to actually view the documentation or understand how this provider works. And we have some example files too about the Terraform telemetry subscriptions and how you can create those. So this is the example that we'll actually be going through together here. So let's start off by giving an overview. First, we're going to modify any variables that we may have to match the IPs of the source and receiver in our own environment. Then we need to make sure that Terraform is actually installed and running properly. So we can run a Terraform init and make sure that we get the most updated version for our iOS XE provider. Then we can run a Terraform plan to make sure that we know what's going to be changed in our config. We know that everything is going to go as expected. And lastly, we can run the Terraform apply to make those changes. Lastly, we can validate that everything is working as expected. So rather than talking about this, let's go ahead and view it and see the example live here. So you can see on the right-hand side, I'm logged into my Catalyst 9300X. And first of all, let's just check out what's currently there. So I'm going to show the Telemetry IETF subscription all. And here we can see we have one telemetry configuration here, one telemetry subscription. So now we can actually take a look at what's currently configured. And okay, we see we have it's configured and the subscription is validated. So I actually want to take a look at the more detailed version. Let's go ahead and look at the actual config before we actually apply anything with Terraform. So this is the overview of what we want to create. Basically, we'll be adding a telemetry subscription. We'll be getting some data. So this is for the CPU. As we saw earlier, the CPU data coming in. We want to get it at a certain interval, and we want to send it to a location. In this case, it can be where we have our Docker container running with the TIG stack. So this means that we'll be able to actually collect that data from the telemetry subscription and visualize it later on. So we want to create telemetry subscriptions like this, but now we want to do that at scale. So right now, how we would do that is we would need to manually add maybe CLI to go in and configure multiple different subscriptions. But in this case, we're actually going to use Terraform to do that. So let's take a look, first of all, at our Terraform file. We can see here that we have a resource and we're going to be adding in all the different information necessary, like the subscription ID. This is what we saw over here in our example config. We have a subscription ID. We'll also have the source address of where we want to get the telemetry from, as well as all the receiver information. So this includes the IP address and the port and protocol, which is included in this line of CLI here, where we have the IP address, the port, and the protocol. We can take a look too at our variables file. So this will need to change based on your current environment. But in this environment, we have a username, password, and also our host URL, so how we can actually access this. This is not a file that in production you would want to share publicly with others, but in this case, for our demo environment, we can share it here just as an example. So now that we know what's going to happen, what we actually have within these files, let's use Terraform to actually configure a few different subscriptions. So to start off, we can run a Terraform init here. And this makes sure that Terraform is actually initialized, it's running, and we're using the correct version of our providers here. So now let's run a Terraform plan. And in this case, we can see there are 8 to add. So in this case, we have 8 different telemetry subscriptions that we'll be adding to our device here. So now that we feel comfortable with what Terraform is going to do, let's go ahead and apply it. I'm just going to confirm, yes, we do want to make the change. We see from the Terraform side, we have 8 resources that were added, or those are the 8 different telemetry subscriptions. And over on our device side, wow, we see a lot of logs coming in. So we see that some things were configured, some telemetry, something has happened, but now let's actually take a look at what's going on. So here, before we just saw the one telemetry subscription configured, and now we see that all of these different sustainability related XPaths or subscriptions were actually created here. So we can go ahead and take a look at one just to do the validation. So let's go ahead and take a look at maybe the first one here. We can confirm, yes, okay, this one is configured and validated. Now let's look at the actual config here for this one. So we see that Terraform actually created this subscription as well as 7 others. And we can see the different XPath that was provided. So this one is giving us some data about our environment sensors over here. So this will lead into the sustainability use case and the smart buildings and additional examples that we'll go through throughout the rest of the session. So I'll pass it back to Jeremy for that.
Cool. Thanks for that demo, Story. So in this demo, we saw Terraform be used to enable a lot of telemetry subscriptions. So we're going to double click on those telemetry subscriptions in the next slide here. First, we wanted to understand a little bit more about the environment that we have the sensor deployed, or the switch that's sending us this telemetry. So in this case, we're talking about a smart building use case where we're using Catalyst 9300 series switches or stacks of switches where we have a lot of PoE endpoints connected. In the demo lab or the smart building environment here, we have things including PoE powered desks, lights, lampshades, and a MacBook laptop charger. So we have a variety of PoE endpoints that are powered directly from the switch. And that's why we want to instrument this feature so much in so much detail. There's a lot of features that we have available to instrument. We can do that through the Cisco Catalyst Center. There's a PoE analytics or PoE dashboard on there. But in today's example, we're using the third-party tooling of the Grafana as part of the TIG stack, as part of the Docker container. So let's talk a little bit about which of the Yang APIs are used. We just saw Story use the Terraform tool to turn on these 8 or 9 telemetry subscriptions. So here we've laid out the features, the data model, and then the XPath that's required to subscribe to that feature, that data model. We also put some details down here at the bottom about some of the data that's going to be contained when you subscribe to that information, or when you subscribe to this XPath or this feature, this data model. So for example, when you subscribe to the environment opper data model, you'll see a counter there for the current reading of the temperature sensors. For the fan state speed, for example, you'll see that there's a fan state container or folder, and inside that folder is the fan speed leaf. So we can query or subscribe to that fan speed leaf, and we'll immediately either know how fast the fans are spinning, as well as how hot or cool it is in the various sensors that we have in the switch, and so on and so forth for all of these different data points that we have here. So let's double click into some of them in a little bit more detail here. Of course, we've seen the data model, we've done the get from the netconf for the GNMI API, and then we've turned on the subscription. That subscription is now pushing this data at this update interval that we define, which I think is 60 seconds or once a minute. So here we can see some of this data being represented over time. Now we see the fan speed is at a consistent rotation here, but then we have the memory instrumented over time, so we can see if there's device features that are requiring more use or more CPU that's running hotter for any reason. And then we can also instrument the physical temperature of the sensors here over time. And here we can see that the sensor where the air is coming into the device is around 32 degrees. And where it's leaving the device is around 40 degrees. So we can immediately understand some characteristics of the data center or wiring closet. We can also look at some other things, including the power supply, so we can understand what type of power supplies are inserted, how many, and then what's the utilization of those power supplies. And then same thing for the PoE system and subsystems. We see details about the PoE systems in detail. We have the next slide here that talks about the 3 telemetry configurations that we enabled to support the PoE use case. Right? So we have PoE port details, we have PoE switch level details, and then we have PoE stack level details where we have a stack of switches that share PoE data amongst themselves. We put some data here about the Yang data model so we can understand precisely what data is being exported. And then we have a pretty nice PoE dashboard on the next slide here. The Story can describe and show us in a little bit more detail about.
Yeah, so let's take a closer look at this one. So this is our telemetry dashboard that we have, all dedicated to PoE. And so you can see there are a lot of ups and downs, and basically what's going on here is we're turning on our PoE devices or making them active or up during the day when everyone is at the office or utilizing these devices. And then at the end of the day, when everyone goes home, we'll actually be turning those devices off to actually save some power, save some energy here. So we can actually zoom in and see kind of over the course of maybe one day here, what actually changes. And so we can see the exact consumption of power that we have at night or the wattages whenever these PoE devices are turned off versus during the day. So we can look at any of these individual data points here and better understand what is our power or energy usage and how can we be more sustainable in the future. Taking that a step further, we have lots of different dashboards or ways to actually show the telemetry data that we're actually collecting from all of our devices. We can do that in these chart formats or even in tables. So here we're looking at different devices. We can see which interface actually is pulling a certain amount of power. And we can look at this over time again to make better decisions about how we can be more sustainable in the future. Maybe we can see that one branch or one switch within a branch is pulling a lot of power, using a lot of energy, and come up with ways to actually start to conserve energy or be more sustainable in the future. So with that, this concludes our last demo, and now we can move into some resources to wrap up the session. So there are definitely a lot of different telemetry use cases specific to sustainability, and we were only able to cover a small portion of that today. So there are definitely a lot of other resources out there for you to look more into how you can be more sustainable in the future and use telemetry to get more details about how to do that. So we have a couple of examples here, and you can go in and check out these different dashboards to build up your own if you're interested in learning more. We also have GitHub and Grafana examples. So here, this is where we're talking about PoE, like we just saw in the example in the demo previously. So if you want to get hands-on with this, you can dive over here into the Cisco MDT PoE example. You can see the guide, the step-by-step on how to get more invested in this use case and build up your own telemetry dashboard like the one that we just saw together. We have a programmability configuration guide, and this is the latest one that we have for 17.14. So this is a one-stop shop for all the different use cases and examples that you may be looking for. This is not limited to just telemetry, but you see that model-driven telemetry is a big portion of this as well. So anything telemetry related, you can check it out here, as well as anything else related to programmability and automation. So that starts with day 0 and the zero-touch provisioning. It gets into our model-driven programmability. So earlier we saw some use cases with netconf and GNMI. And of course, we have the telemetry section as well. We also have a couple of different white papers that are available. So the first is an overview of the API. So this is related to anything Catalyst, programmability, and automation. So we have a lot of use cases here or examples, code samples that you can use. you can pull those into your environment and see exactly how you can use any of these solutions throughout day 0 through day N. Next, we have a white paper that's dedicated specifically to model-driven telemetry. And this one is new, recently published. So any questions that you may have about telemetry, they're probably answered over here in this white paper. So make sure to check it out. And we want to say thank you so much for watching and attending this session. We hope you found it valuable. If you have any questions, please let us know. Thank you.